On example 4, I purposely blocked out the picture just because I think it's good for us to draw our own. So let's look at what we have. Two forces of 15 and 22 newtons act on a point in the plane, and then the angle between the forces is 100 degrees. So let's draw what that looks like. We've got 15 newtons and 22 newtons. It doesn't have to be perfect, with 100 degrees in between the two angles. That's really all they give us to go by. And they want us to find the magnitude of the resultant vector. So the resultant vector is either going to be a golf ball problem or a dog walker problem. And so you look at this picture, and this looks like the dog walker problem. So I will set up my parallelogram, draw a parallelogram in order to find the resultant force. There it is right there. Now what we've done is we've drawn that resultant right through that 100-degree angle. And so please notice that it's not going to split 50-50. That's not going to be 50 on one side and 50 on the other side, because one of the forces is stronger than the other. So you would expect the resultant force to be closer to the stronger force. So what are we going to do? Well, since this is trigonometry, a lot of the times we're going to have to deal with a triangle, and that's exactly what we want here. Notice that we have actually drawn a triangle inside of our parallelogram. So we're going to go back to the last slide and kind of use some of those properties. And notice in problem number 2, or property number 2, adjacent angles of a parallelogram are supplementary. That's kind of the big one that we would need here. And so when I look at this parallelogram, I know that this angle right here is 80 degrees. This angle and this angle are supplementary. I know those two angles add up to 180, and that tells me that that missing angle was 80 degrees. That's huge. I also know, because opposite sides are congruent, I know that side is 22. And so if you notice inside your triangle, think about the temple runner. The temple runner is running around here collecting tokens. It looks like he's going to get SAS. We have a triangle with SAS. That points us to law of cosines. It's case 3, law of cosines. And so knowing SAS tells me which formula to use. So with either of the two formulas, law of cosines or law of sines, it's important to establish this partnership. I know that R and that 80 are linked together by the formula. And so the formula is going to look like this. R squared equals 15 squared plus 22 squared minus 2 times 15 times 22 cosine 80 degrees. The most common mistake that people make is they don't find that 80 and they just plug 100 in right there. That's not going to cut it. If you think about what that would find, if you use the 100, it would end up finding this side, and that's not going to be the same thing as the resultant force. If I'm thinking about my dog walker problem, that would be the distance between the two dogs' heads, I guess, and that's not what I'm finding. I'm trying to find the resultant force. So good news is we're just going to plug that into a calculator. Let's see what happens. 15 squared. $594.4. We're getting R squared is about 594.39, I guess. I'm not going to write down the whole thing because I'm not finished with R. To find R, I take the square root. And I get about 24.4. 24.4 newtons. Now, before I circle it, I might just look and see if that makes sense. 24.4 newtons. Yeah, I'd say that makes sense. That's the resultant force of 22 newtons and 15 newtons. Answer is 24.4 newtons. So then, before we move on, I just would like to draw another picture. I want you to think about how this picture works. And think about a force of 14 newtons and another force of 18 newtons with a 50-degree angle in between them. So, I don't know. It doesn't have to be perfect. Picture's going to look something like this. So if I was going to find the resultant force, draw your parallelogram, draw that diagonal, there's the resultant force. If I was going to continue, I would need to find this angle is 130. We know that because 50 plus 130 is 180. And I would know this opposite side is 18. I'm just trying to find a triangle, and then the temple runner can tell me what to do from there. That's side angle side. I know that's case 3. I know that's law of cosines. I plug it in my formula and find that resultant.